Hi there, welcome back. I'm going to be talking about my DevOps project version 2 this time. So in version 1, I included a little walkthrough of how to install the project and upload it and get it up on all Amazon servers with the Cloudformation script in basically just a few clicks. The same thing applies for this one, but I'm just going to skip over that and go right into the updates to the app, show the app a little bit, then talk about the code and some of the decisions I made. So I've already created a user, so we're just going to log in to this user, and I'm going to show you the updates to the app. So in the version 1, all I did with the Lambda function was send a basic random string, and then it would send back the SHA-256 hash of that string just to show the Lambda functionality. But now I've got a little bit more functionality, and I wanted to show that off. So this one, we allows it to upload a file. So we're just going to grab a puppy and send it to S3. And what this is doing is it's sending it to the Lambda function. The Lambda function is generating a pre-signed post URL, sending that back so the React app can directly send that to S3. This is a little bit more efficient. Again, we're using a picture, so I could send that through the API gateway, but it's just a little bit more efficient, especially if you wanted a larger image to upload, or you want to just, it makes it more efficient, future-proofs it. So what that does, uploads it to the S3 bucket, and then the S3 bucket grabs that image with an event source mapping, runs a image recognition function on it, and updates the DynamoDB table with that, and then we can simply hit get images, and that grabs the image from the S3 bucket and then lists the top 3 labels by the image recognition function. So that's how it works. That's a little bit of update. It's still a fairly basic app, but I'm going to go through some of the decisions I made in the code. And let's just throw one more just to make sure it's a little bit different. And yeah, so let's try that one more time. And yeah, so this one, car wheel, wheel tire. So that's basically how the app works. And let's talk about some of the code with regard to that. So let's start with the API template. This is the one that uploads the serverless, all the serverless stuff. So if you remember from the first video, if you watched it, we had this basic launch script. We create an S3 bucket. We launch the SAM template, which creates the serverless one, and then we the serverless apps. Then we launch the CI/CD pipeline for the code commit and that sort of thing. So when you update it in code commit, it automatically rebuilds the app and then sends it to where it needs to go. So let's just go through some of the code and talk about this. So I'm just going to fly through this. We're basically creating an image store bucket for storing the images. We're creating an API gateway with the Cognito authorizer. Again, this had to use the Swagger template to get some of the cores and some of the nitty-gritty configuration working with API gateway. Then we have the first Lambda function. This is the post one. This will generate a pre-signed post URL for the app to upload images to. And as you can see, we've created an environment variable for images store bucket. So the Lambda app knows which bucket we're looking in. And then this second app is for getting the links. So this one, you ask the Lambda app for all the images from a certain user, and it sends it back. Again, we have this environment variable, this one. And this one is the event source mapping to trigger the Amazon recognition function. So as you can see, it's on the event, process image event, that's the name of it. We have an S3 event when the object is created. So anytime an object is uploaded to S3 to this specific bucket, it runs this app, and that uses the Amazon recognition service to recognize the object in the image, and then updates the DynamoDB table. Okay, so this stuff is just for the user pool for Cognito. Fairly basic stuff. And then we got the images table created by DynamoDB. And this is just basically the primary key is the user. So that's the user, the logged in user. And then the sort key is the S3 key. Well, technically it's the file name, and you combine them to create the full S3 key. And so this allows you to make it very easy to, if you want all the images, you just send the user, and then it just gives it back in one API call, so you don't have to check DynamoDB a bunch of times. It saves the write capacity and the read capacity units. And then if you want a specific one, you can send the S3 key with the user to get the specific image. So it's quite set up quite well because we only have one write and read capacity unit provision. So I just wanted to keep it nice and cheap and just have it basically be able to just sit up on the web and not basically cost much money per month if no one uses it. So then we have a couple outputs for the Cognito client and the ID and the API gateway URL. This will output them, and then when we build the app with code build, the React app with code build, it includes it as environment variables, so it can access that and work nicely. Okay, let's go through some of the Lambda apps. So this is the first one, the upload image. So what we got to do first off is get the JWT token from the header and decode it to get the username. So whenever you send a request to the API gateway, you include this authorization header, including the JWT token. And we want to split the JWT token into its three parts: the header, the payload, and the signature. We actually only need the payload, but that's fine. So we will add a little bit of padding to this, just modify it so we can actually create the binary whatnot, so we can read it nicely with this function, and then this outputs a JSON, which we can load JSON loads, and then we can grab the Cognito username from that key value list, the JSON. Okay, and so once we have the username, that's kind of the main thing that we're listing it. So we have the bucket name, and as you remember, when we went over here, we outputted the bucket name as an environment variable right here. So that's why it knows where to look for in the image bucket and just prints it for debugging. And then we have the expiration time. We have the file name, which we include in the body. So when the user hits upload for the file, it actually sends the file name, and that uses that file name to generate the pre-signed URL. So that's what we're doing right here. So we include that in the body of the file name, and we can create the full S3 key by combining the decoded username from the authorization with the file name sent in the post request. So what do we do here? So this one is just for getting this lists all the objects for the bucket and the prefix, which is just the decoded username. So I didn't want to have a bunch of S3 calls. I wanted to minimize the number of S3 calls, so I didn't want to call S3 every single time and iterate through the list. I just wanted to get them all in one S3 call, and then I can check if the image already exists. So that's what this is doing. So contents is a key in the get list that returns it. If it's not there, that means there's no objects in the list. So then we can just be like, okay, it's empty. So this is the first upload from the user. We generate the pre-signed post URL, including the bucket name, the S3 key, and this will allow us, the React app, to directly upload to S3. You don't have to send the data through API gateway. Just saves cost, and if you ever wanted to make it better or upload a bigger image, that would be the way you would do it. And then we create a response. So I just added this little image exists for the React app to use. Okay, doesn't exist, we're all good. Use this pre-signed URL data to upload the image. And then we want to check to see if the max photo reaches. So right now we can just have about 10. So if the key count is greater than 9, the maximum of images have been reached. So we just send response max limit equals true, and then saying, hey, you can't upload any more images. I just wanted to keep it nice and simple in case someone decides to spam the server and somehow rack up my AWS bill. So I just wanted to limit that. And then we want to see if the photo exists already. So we use the S3 key and we check in this list. So this lists all the images in the bucket and the username. And we just wanted to check there, and if we find it, we send back the pre-signed URL. So this is different, the pre-signed post and the pre-signed URL. The pre-signed URL is used for viewing the image. So it says, hey, this image already exists. And if you wanted to view it, here's the URL that you would use to view the image. And then, so we say image orders is true, so the React app will process it properly, and then it can use that image to display if we wanted to. The current React app doesn't do that though. And then if it doesn't exist in the bucket, then we generate the same pre-signed post URL, which the app can use to upload the image directly to S3. And then that response is just sent back with the status code 200. It means it's all good. And yeah, right now we just allow everything from the cross-origin resource. Okay, let's go on to the next one, the recognition app. So this is the recognition is an Amazon service that you can just basically send them an image, and it will check that image and label it with all the objects that it's found. So we get the DynamoDB table, and as you remember, we created that DynamoDB table here, and we called it images v2. This doesn't have to be unique. I mean, unique for your account. You can call this whatever, but I'm sure there's plenty of DynamoDB tables called images v2. So this doesn't have to be unique to all AWS, just to your account. Then we get the bucket and the S3 key from the event source mapping. So when an image is uploaded to S3, it sends that event source to Lambda, and it includes a bunch of events in there, and you kind of just unpack it. You just have to view the event and figure out where the data you want is. So that it sends the bucket, and then we want the key, and then just creates the bucket and the key. Yeah, and then just grabs that from the event. And then we want to detect the images. So it's simple, one line. The recognition client simply detect labels, and it points to the image you want to do. And I said, just give me 3 labels. That's all we need right now. And then we want to process the label list, put them in a little bit of a dictionary, and then we can, this is just for debugging, and we can update the labels in the DynamoDB entry. So when the original pre-signed URL post URL was created, it included it created a DynamoDB entry, and this just grabs that and updates the label list for the labels, and creates a time to live. So, I have a bucket policy on the S3 bucket, which deletes them after certain days, and this will also delete the the S3 lifecycle policy, delete the images, and this will also delete the DynamoDB entry after a certain amount of time. Okay, then we have the get images one, and so this is the same JWT token from the header. Same deal for looking at which buckets to look at. This gets a list of all the entries in the DynamoDB table for the user. So so every user has a big list of their entries. This includes the labels. And then we get the big list of the users from S3 bucket, and we just go through it. First off, we check to see if the DynamoDB entry exists in S3. So there can be a little bit of a break because it creates the DynamoDB table, and if for some reason the upload fails, you'll have a DynamoDB entry, but you won't actually have a image in the S3 bucket. So this just checks that, and if it's not found, it just prints not found. But if it does exist, we want to create the pre-signed URL and add it to the image list, because we want a full list of pre-signed URLs, so the React app can just grab that list and then display it in the app. And so then we just JSON dumps that image list and send it back. Okay, so that is how the serverless part works for the app. Let's go through the pipeline. So we have the pipeline. This is what we use to upload the React app and include the CI/CD. So it creates a code commit, and when you update the code commit, it rebuilds the app. And we'll just go through it. So basic artifact store bucket. This is where we're storing our bucket. And this is the static website bucket. So we are using Cloudfront to serve the S3 bucket. So we want the static website bucket, and you gotta create a few specific features in the S3 bucket to make sure the Cloudfront can use it properly. So we wanted to lock the bucket down so just Cloudfront could use it. And if you go to these links, you can see the direct details of why you needed to select these options, but we want to lock it down. Bucket ownership. Apparently the VS Code doesn't recognize this, but if you go to this link right here, bucket owner enforce is what you want. This basically makes sure that all the objects in the S3 bucket are owned by the bucket owner and not the people who uploaded the image. So we want that so Cloudfront can upload things properly, and we want to just block everything else, so it's just Cloudfront. And we use Origin Access Identity to serve the S3 bucket. This allows you to use HTTPS. If you remember in the V1, I deployed the React app on an EC2 service, but I didn't want that because I don't want to have an EC2 instance just running all the time, costing me money when basically no one's visiting this because it's just a demo project. So now it just sits in a bucket and it's cached by Cloudfront, and it can hang out there and use HTTPS, and it works quite well for a static website like what I have with the React app. We needed to create a bucket policy for the static website, so this is for the bucket, and allows the get object so the resource, this is the bucket, so we wanted to grab the bucket. So right here, we wanted to grab the artifact store bucket. The static website bucket that we're going to be storing in, that's Cloudfront is serving, and we wanted to add this little bit. So it says everything in the static website bucket can be used by the principal, which is the Cloudfront Origin Access Identity. So this is what you have to do. So the ARN for this one, and I had to include this guy, which is this Origin Access ID. So this subs it in there, and then this is just shows you that my Cloudfront service that I've just launched can access and serve this static website bucket. So this is the Cloudfront distribution, and this just walks through how to set it up. So we have the ID is the S3 origin, the domain name is the regional domain name for the static website bucket that I already set up, and then it sets it up Origin Access Identity. So this one is just the label. The join function combines the Cloudfront Origin Access Identity with this Origin Access Identity right here. And we want to cache the get, head, and options features. So we want to redirect to HTTPS. So we want to make sure everything is secure. All the data is sent to and from is encrypted. And then I had to include these cache policies. Compress true. So we wanted to keep it nice and small to save data. And if you go to these links, it shows why you need these specific policies for the Cloudfront to work. And then it points there's an index.html in the static website. It says send that one as the thing to the default root object. And we want to use HTTP2, and we want the default certificate. Again, all HTTPS stuff. So let's move on. So this is it just sends an email to your email when the code pipeline is updated. And so let's go through this. So the pipeline is right here. We're going to get to the code build part in a second. So we have that artifact store bucket, which is right at the top. This is what is uploaded to. So you upload the artifact store to their one, and that grabs that. And we want the CC source. So the CC is the code commit source, and that one, which we grabbed from this import value when we created the code commit repo, and that one detects all the changes, and then it outputs the artifact to the template source to the artifact store bucket. So that's how it works. So it creates it and says, okay, this is the code commit source, uploaded to the artifact store bucket, and then we can move on to the build stage. And this uses the code build project, which is this guy up here. So we want a code pipeline to run the artifacts and the source, but we want to let it know that here's the general build. This is the compute type, like the instance you want to use to build the React app. So again, it creates a Node.js, builds the React app, and includes a Cognito ID and these stuff as environment variables, so the React app knows where to ask for its API calls. And yeah, so then we have that, and then we have the deploy stage, is code deploy, a specific deploy to S3. And so this just takes the zipped artifact from the code build and then unpacks it, extracts it, and then puts it in a S3 bucket, which is the one that CloudFront is pointing to, just to make it serve nice and easily. And this is just the code build role. Allow it to access S3, allow it code build. This is all just stuff to make sure everything has the right permissions to execute what we need to build the function and to upload it to the S3 bucket. And then we want to output the artifact. We actually don't need this, but it's there, and that is fine. Okay, so that's basically it. If we want to look at the code build spec, this is just what the code build looks at, the build spec. So we need to install the specific Cognito identity JS. This is written by Amazon, but Amazon uses Amplify usually for Cognito, so they're kind of trying to push everyone towards Amplify. But I didn't want to install like the full Amplify package. I just wanted to cut it down and make it a little bit smaller. So I just used the package that I want from that, and this is what allows me, the React app, to talk to Cognito and get all the JWT token and everything. This is all just so I can view the build on how it's working, and then uploading the right data to the environment variables, and then it outputs this artifact, adjusts the build. So again, when it compiles it, we just want the build, the static website build for the React app, to be sent out and saved. Okay, that is it for the code build, the CloudFormation stuff. I hope you enjoyed this. Went a little bit longer, but you know, I had to explain some of the code. So yeah, I hope you like that, and thanks for listening.